Okay, so I guess we're taking requests. That was a request, and we're here for part two of circles and ellipses, and we're going to come back to our seriously our old friend. Um, what do you call it? Completing a square. So it says classify the conic given by 4x squared plus y squared minus 8x minus 8 equals 0 by completing the square, then graph. Okay, this might be a little bit of extra work, but we're going to do our best. Um, I'm going to group the x terms together, and I'm going to put the 8, the constant, on the other side of the equal sign. I'm going to factor out 4. And then remember for the completing the square that we did earlier in the year, the key thing is the b over 2 squared. Voila. And here, so negative 2 over 2 squared, well, that equals 1. So now the big question is, what do we add to the right side of the equation? And I know it's tough. It's really tough. You notice that it's 4 times 1. So you have to know that you're adding actually 4 to both sides. You're not just adding, what do you call it? You're not just adding 1 to both sides. So we get something like this. Okay? And remember on the last slide on video 1, I said something that the last term here had to be a 1. So we're going to divide by 12. So let's see. Okay. And we can simplify, and we will have the an equation of an ellipse. So this is an ellipse. I always like ellipses because they're separated by addition, and they're very much like circles. You know, it's great with this. Oh, wait a minute. Whoops. This is over 12. There's my equation of the ellipse. And let's classify it since the bigger number is underneath the y. This is a vertical ellipse. And we are going to graph it in 1 second. So I'm going to add some more, add a page. Remember, you can stop at any time. So let me write the equation that we just found, and we'll go over the properties that are important. Okay, let's find the center. So the center in the HK form, that's going to be 1 comma 0. Keep in mind, this could be written y minus 0 squared. It's going to be, let's see, a equals, a squared equals 3. Oh, that's wrong. That's the b term. I got to slow down. Yeah. Okay, so a squared is 12. So 2 root 3. And let's see, b squared is 3. So b equals root 3. Okay, so let's draw a graph. So let's just do a rough sketch. So we know this is a vertical ellipse. We know that the thing is stretched up vertically more than it's stretched horizontally. So let's put in the center. So put a little dot at 1 comma 0. And then we know it's stretched up by a factor of 2 root 3. So there's 1 comma 2 root 3. 1 negative 2 root 3. And then horizontally, it's going to be root 3 comma, root 3 to the right and root 3 to the left. So what's this going to be? To the left, to the left. Okay, so it's going to be 1 minus right here. Remember, this is an approximation, okay? So when we go here to the left, this is 1 minus root 3, comma 0. And this is not drawn to scale because I can see this is a terrible ellipse. It would almost look like it's, well, it sort of looks like it's stretched up vertically. Let's do the major and minor axis. So major axis. The major axis is going to be a length of 2a. And we already know that a is 2 root 3. So that's 4 root 3. Minor, that's 2b. And we know that root 3 is the b. So 2 root 3. All right, that's a lot of work for one problem. And we completed the square. Okay, we're going to finish right now with number 5. It's so weird, like you can't see me, you can't see what I'm doing, you can't see my shadow, like, you know, so this is sort of cool. So let's see, last one. So write an equation of an ellipse with foci at 1, 2 and 7, 2. And co-vertices at 4, 0 and 4, 4. Okay, we really need to draw a picture of what's going on here. So this is the last one. So some of you might think this is the hardest one. I don't know, but this is not meant to be something you can do real quick. So co-vertice at 4, 0. Let's see. So 4, 0. So I'm going to put a dot at 4, 0. And the other co-vertice is 4, 4. Okay, so the co-vertices are given there. So that means that this is not a vertical ellipse. This is going to be a horizontal ellipse. The center is halfway between either sets of the vertices. So the center is going to be halfway between this, so 4, 2. So immediately when you know the center, you can plug real quick into this. Okay, so now we have to deal with the a and the b. So since we know this is a horizontal ellipse, we know that the denominator here is a squared, and the denominator in the second part is b squared. We can find the length of b. So b is going to be 2. So let's see, b equals 2. And we could immediately plug b into the equation and get at least, you know, we could make this b squared, we could erase, actually I won't erase, but we could make b squared into a 4. But now we need to find a squared. But it tells us the foci. So the foci 1, 2. So right here, 1, 2. Foci are usually labeled with C. So I'm going to label this C, and this is 1, 2. And the other point is 7, 2. And I didn't prepare this well, so I'm sort of out of order here. 7, 2. Look at the distance between the center and the, what do you call it, the foci. The distance is going to be 3 units. So this is 3 units. So that means that C is 3. On the front page of the notes, it gave you an equation for the foci for an ellipse. And in class, we will work more with them, and we'll work more with the general form of an ellipse in a problem solving. But you have this equation, a squared minus b squared equals c squared. I say cap. If you use this equation for the foci, we can see that 3 squared equals a squared minus 2 squared. So root 13 plus or minus equals a. So we take the root 13, and the root 13 is going to be our a. When we square that, we're going to get our final answer. So coming down here real quick, b was 2, so b squared is 4. This is the equation for an ellipse with center 4 comma 2, and it is a, let's write it down, it is horizontal, and that's about it. We already knew the coordinates of the foci, and I think we're done. So I want you to, um, here's what I want you to do. On the description page on YouTube, there is a link that um, I was able to make today in class with some help from a classmate, and I appreciate that. I want you to click on the link. It's to a Google form, and I want you to answer the questions on the Google form. All right? This is just an experiment. Try it out, and we will talk tomorrow. And this is sort of my check that you've done the homework, and I will see you tomorrow in class, and great job. And thanks for bearing with me.